Hello and good morning and welcome to another class in sustainable energy technology. In the last few classes, we have discussed solar photovoltaic technology. In today's class, we will start a new section on bioenergy and biofuels. So bioenergy and biofuels are basically sources of fuel and energy that can be used for thermal energy or electricity generation that is sourced from biological sources. Now these biological sources creates biomass, bioenergy and biofuels which are basically hydrocarbons. And the way these hydrocarbons are used to convert them into energy is through various types of combustion processes. So one may ask, how is this a renewable or sustainable technology? Because what you are doing is burning hydrocarbons and generating CO2. The key here is, unlike fossil fuels, where you are mining coal, mining petroleum and mining natural gas, here you are using biological resources that are naturally growing on the surface of the earth and using that to convert it into energy through combustion processes. Therefore, the carbon that is there in these biofuels and biomass materials has only recently been absorbed from the atmosphere. So green plants, autotrophs, and from their animals and other living organisms are gaining carbon primarily through absorption of CO2 from the atmosphere through photosynthesis of green plants. During the photosynthesis process, green plants convert the carbon dioxide that is in the atmosphere into sugar, starch, various types of organic matter. So when you are using this organic matter for combustion and generating energy, you are not adding any net carbon dioxide into the atmosphere. What was absorbed maybe a year ago or a year and a half ago is being released by the combustion process. Hence, such fuels are called carbon neutral fuels. That is, ideally, they are not contributing anything additional to the carbon cycle that is already occurring on the planet Earth. In contrast, fossil fuels are basically extracting carbon that has been sequestered within the ground for millions of years. They have been locked up for many millions or many hundreds and thousands of years on the ground. So when you are burning these fossil fuels, you are adding carbon dioxide that was not in circulation in the biological system or in the atmosphere for many years. So you are adding carbon dioxide to the system which was locked away in these reservoirs of coal, petroleum for millions of years. So that is the difference between why the fossil fuels are adding CO2 to the atmosphere, whereas biofuels ideally will not. However, there are concerns regarding whether this is actually occurring and to what extent, number one, and number two, whether the biofuel production and consumption processes themselves are sustainable overall. We will discuss these points as we go along, as well as we will look at the technologies associated with biofuels and bioenergy technology. So here is what I would call an ideal biomass cycle. You are producing the biomass in agriculture, in farms, or in waste residue products. That biomass is being transported to a central section where it is converted into usable fuels in a biorefinery process and conversion. Then it's distributed to say transportation sector as bioethanol or biodiesel that can be used to run cars and trucks. Then this CO2 is being released in the atmosphere by combustion, and it is being then again absorbed by the green plants that are being grown for this biomass production process. And that way This process is a cyclic process and is a carbon neutral process under ideal conditions. So let us understand how much biomass resource is available worldwide. It is estimated that 0.1% of the total incident solar energy, which is around 10 to the power 24 joules per year, is being converted to biomass by photosynthesis. Okay, so 0.1% of this is 10 to the power 20, correct? 10 to the power 21. So that seems to be a large amount. Okay. However, this is only 6 times the energy that is being used by humans in an year. Okay. So if the total energy that is being converted by photosynthesis to biomass resource is 4 into 10 to the power 21, then this is only 6 times. So the amount of energy being consumed by humans is of the order of 10 to the power 20. Okay. So the ratio is just 6. And this biomass is not only utilized for human use, but it is also supporting the entire food production, all the food, the edible vegetables, oil crops, etc. that we humans rely on, as well as the entire natural ecosystem, the terrestrial plants, animals, the marine ecosystems. All of this is dependent on this biomass resource that is being created by photosynthesis, by green plants. Hence, human beings cannot simply use all of it. Okay. And today it is 6 times the energy. As the human energy consumption grows, as it is projected to grow in the 21st century, this ratio is going to become lower and lower. So it's a renewable resource, but it's a limited resource. It is far less amount of it is available for sustainable extraction compared to wind or solar. So that is one concern, that if you extensively use bioenergy and biomass in all your energy systems, then it will severely disrupt human food production as well as natural ecosystems. So that is a concern that needs to be addressed. So excessive use may jeopardize food production and cause ecological damage. So it's renewable but not necessarily sustainable. May have zero net greenhouse gas emissions if CO2 emission during use is less than that absorbed during growth of the biomass crop. Okay, so the biomass crop is growing, it is absorbing CO2. If the net greenhouse gas emissions during its utilization is less than what is being absorbed by this crop, then yes, it will have net zero greenhouse gas emissions. However, pollutant emissions will still be present. So for example, if you are burning it, the NOx, the SOx, the soot emissions, the particulate matter emissions, those concerns will still be there. And this we see when you are burning the agricultural residues. Of course, you are not adding any net CO2 into the atmosphere because the agricultural residue itself is absorbing CO2 just 6 months ago from sunlight using photosynthesis process. But the smoke due to this combustion process is harmful to the environment and human health. So using biomass resource may not cause global warming, but it may still be extremely harmful to human health and general ecology. Okay. Despite these issues, 63% of the net global renewable energy use is from biomass. So today, even today, and I will say why it is even today, 63% of the net renewable energy that is being consumed by the world is from biomass. However, mostly this is traditional biomass like firewood, cow dung cakes, wood car, charcoal, etc. So in rural communities in India, in Africa, parts of China, Southeast Asia, Latin America, people use firewood, cow dung cakes, wood char, etc. for their day-to-day cooking and heating needs. So this is the primary way in which biomass sources are still being used presently, and it contributes to 63% of the total net renewable energy utilization that is being used done by humans today. This is a problem because these types of traditional biomass use produces a lot of pollution, and that is extremely harmful to human health. So the recent trend has been, as you can see in India, we are trying to replace firewood using LPG cylinders in the rural communities, and this kind of initiatives are being done everywhere because clean access to clean energy is very important to improving the health of rural and communal households. And firewood smoke is not clean. However, if we do this, if we convert firewood based traditional cooking systems with LPG, remember LPG is a petroleum product, a fossil fuel product. So while we are decreasing the pollution, we are actually increasing the greenhouse gas footprint of India. We are converting from bioenergy based energy utilization to fossil fuel based energy utilization. So ideally what we should do is convert from the traditional biomass based energy utilization to an alternative renewable or sustainable energy utilization process which is also clean. This may be a modern biomass system, we will discuss some of them where the pollutions are significantly less, or other types of renewable energy systems like solar cooking systems, etc. Apart from this traditional biomass, where the most of the organized biomass industry development is happening is on commercial grade biomass. These are solid, liquid or gaseous fuels produced for industrial heating, electricity generation and as petroleum substitute in transportation. Okay. Commercial grade biomass, it can either be solid, it can be liquid or it can be a gaseous fuel that is being utilized for heating in the industries, for electricity generation and as an alternative to petroleum based fuels. Examples include bioethanol, which is a substitute for petrol, biogas, which is a substitute for methane, and wood pellets, which is a substitute for coal in the furnaces that is generating heat or electricity through steam turbines. So what are the various sources from which you can get biomass? One source is forestry crops and residues. So for example, the wood industry generates a lot of sawdust and waste wood chips. You can use those as a fuel source, as an energy source. So that is a waste forest residue that is being used as a bioenergy source. Similarly, you can use agricultural crop residues and agricultural crops. So you can grow dedicated oil crops from which we extract that oil and use that to create petroleum substitutes, or you can use the residues, the residue of agricultural systems like straw, like rice husk, like sugarcane bagasse, and instead of burning them and generating a lot of pollution, you can convert them to useful biofuels, which can be used again in the transportation industry or industrial heating and electricity needs. You can use municipal sewage. Sewage is basically organic waste. Maybe you can use it in a biogasification facility to produce biogas and replace natural gas with that. That is another way to utilize the biomass. And again, all these three, and you can also use municipal solid waste, compacted municipal solid waste from garbage, etc. Again, you use it through biogas systems to biogasifiers to produce biogas. So we will discuss processes that can utilize all of these methods and generate useful bioenergy. Animal residues, cow dung, very common residue, correct? Then all these animal farms will create a lot of animal waste products that can be used as a biomass resource. Then industrial residues. So many industrial processes will also produce lot of organic residues like sugar mills. like like specific food manufacturing plants, like potato chip manufacturing plants will also have a lot of waste biomass from potatoes, etc. Okay, so all of these can be used as biomass sources, and that significantly improves two aspects of sustainability. Firstly, what was a waste, and we had a huge problem of how to treat that waste. Forest residues, agricultural residues, municipal waste, sewage waste, animal residues, industrial residues. So this waste treatment is a big problem in the world as well as in India. Untreated waste is toxic to the environment. So here we are giving a solution to treat this waste and create useful sources of energy. So this is kind of the idea of a waste to wealth or waste to energy paradigm, where uh, uh, biomass based waste to biomass transfer technologies have a very good economic and sustainability case to make. Okay. So this also allays the fear that we are using biomass resources that is competing with the needs of ecosystems as well as food production. Instead, we are focusing on the waste that is generated by human activity and trying to convert that waste into a useful resource. So there we are no longer competing with natural ecosystems or food production, but rather uh, treating what is a toxic byproduct of human activity and use it for energy and thermal energy generation. So these are some of the things that we are talking about. Agricultural residue like straw, right? Algae, we will discuss this. Algal ponds is a potentially big source of future biomass production. Dedicated energy crops, this is a little bit more problematic because it is will compete with food production. Forest residues from sugar mill plants, like wood wood plants, etc. Municipal solid waste and wet wastes. So in 2018, 67.2% of total renewable energy used, which was around 81 exajoules, was bioenergy. Next is hydro, then came wind, solar, and then geothermal. We have not discussed geothermal yet, we will discuss it in the future. Now clearly, wind and solar are growing at an extremely fast pace. But even to this day, most of the energy that is being used from renewable resources is bioenergy, and most of it is traditional biomass. Okay. So if you see this distribution by continent wise, you see most of the bioenergy used in Africa is most of the renewable energy utilization in Africa is green bioenergy. So traditional biomass dominates Africa, okay, which is relatively undeveloped. Similarly, in the Latin Americas, so Southern America, also this section is mostly traditional biomass, but also there is a significant amount of commercial grade biomass generated as well. You have a lot of bioethanol generation in Brazil particularly. So this is a combination of both traditional and modern bioenergy. Asia, also a combination of traditional and modern bioenergy. Lots of rural communities use modern bioenergy, traditional biomass, whereas modern bioenergy farms are also growing up. In Europe, most of it is commercial grade modern bioenergy and biomass resources. So this is primarily EU and Europe and USA. So there, most of the biomass or bioenergy utilization is modern biomass systems. Okay. But in all continents, bioenergy dominates the renewable energy production systems.